In this problem, we need to show that y squared times the second derivative of y with respect to x minus x times the first derivative of y with respect to x plus y equals to 0, provided x is given by a cos theta plus b cos theta and y is given by a sin theta minus b cosine of theta. So let's try. We'll begin by squaring x squared. So here we have a times cosine of theta plus b times sine theta squared. So let's expand this, and this is going to give us a squared cosine squared theta plus 2 times ab cosine of theta times sine of theta plus b squared sine squared theta. So this is x squared. Let's label this as equation number 1. Then we take y equals to a times sine theta minus b times cosine theta. Now what we'll do, we'll square both sides, and this is going to give us a squared sine squared theta minus 2ab times sine theta times cosine theta plus b squared cosine squared theta. So let's label this as equation number 2. Now we'll add 1 and 2 together. And doing so, we get x squared plus y squared equals to. So here we have a squared cosine squared theta and a squared sine squared theta. We'll take a squared as the common factor. This will be multiplied with cosine squared theta plus sine squared theta. Then we have b squared sine squared theta and b squared cosine squared theta. So if we take b squared as the common factor, we have b squared multiplied to sine squared theta plus cosine squared theta. Here 2ab cosine theta sine theta and negative 2ab sine theta cosine theta, that gets cancelled out, and we know cosine squared theta plus sine squared theta, this is an identity with a value of 1. So we have x squared plus y squared equals to a squared plus b squared. So let's label this as equation number 3. So this is the simplified form. Now we'll perform an implicit differentiation. All we have to do is take the derivative of equation number 3 with respect to x. So we have, let's first write it down, derivative with respect to x of x squared plus y squared, which is equals to derivative with respect to x of a squared plus b squared. The derivative of x squared, so that's simply 2x, plus derivative of 2y will be 2y times dy over dx. So here we have used the chain rule, and this is equals to derivative with respect to x of a squared plus b squared. Here a and b are constant, so that means a squared plus b squared is also going to be a constant, and derivative of a constant is always 0. Now what we can do, we can factor out 2 and divide by 2 to get x plus y times derivative of y with respect to x. Now this is equals to 0. So let's label this as equation number 4. Now what we'll do, now we will take the derivative on both sides with respect to x. So we have x, derivative with respect to x of x plus y times dy over dx equals to, so derivative of 0 will be 0. Now let's find out the derivative. The derivative of x with respect to x, so that's equals to 1 plus derivative with respect to x of, we have y times, so here we have dy over dx. So we can also write in notation form as dy over dx will become y1. So this is the first derivative of y with respect to x. So y times y1 equals to 0. So this is going to give us 1 plus. So we'll take y and multiply it to derivative with respect to x of y1 plus y1 times derivative of y with respect to x equals to 0. Now we'll transpose y to the right hand side, and we have y times, we have derivative of y1, which is the first derivative with respect to x, that gives us the second derivative, plus y1 multiplied to, so derivative of y with respect to x, so that's the first derivative in notation form, equals to negative 1. Fine. Now what we'll do, we have y times y2 plus y1. Now in place of y1, what we'll do, from equation number 4, we can rearrange equation number 4 to get dy over dx, which is y1 equals to negative x divided by y. So we'll use this value So let's substitute here in place of y1. Multiply to negative x over y equals to negative 1. Now we'll multiply throughout by y. That gives us y squared times y2 minus x times y1 equals to negative y. Now we'll transpose y back to the left hand side. We have y squared. So y2 is second derivative of y with respect to x minus x times first derivative of y with respect to x plus y equals to 0. And this was what we were asked to prove. So let's verify that. So we have y squared times second derivative of y with respect to x minus x times first derivative of y with respect to x plus y equals to 0.